So, I'm going to start going over these. Unless you want more time to do it. It looks like you all want more time, so I shall wait. No, it's put out there, but I paused it. Okay, so these first four, you just follow the pattern. You don't have to show any work because I know that 45, 45, 90 is a square root 2. And across from the 45 was given as 5. So I just put 5 here and 5 here, and then I'm just going to put 5 square root 2 because this one followed the pattern. These, on your test, you'll have more of these than the other kind. I'm only going to have like 2 of the spicy ones. I'll have like maybe 6 of these to make, that you're just following the pattern. I'm not going to challenge you that much. It's not going to be a big part. But like I said, for those who are going to college, they kind of need to know how to deal with radicals. And this is about the only place you would do that in the curriculum. So this one follows the pattern also, and it's still a 45, 45, 90, which is a square root 2. But this one they gave you across from the 90. So a square root 2 equal to square root 2. Now, you didn't have to show this work if you didn't want to. If you could just look at it and go, oh, 2 and 2, that's fine because that's the goal is for you to learn the patterns. But if you didn't know, you would just divide by square root 2, and these 2 square root 2's cancel out on each side, so a equals 2. Anytime you are not given the smallest side, you have to solve for the smallest side first. Or, in this case, just follow the pattern. So over here, now this is a different pattern because this is your 30, 60, 90, which is a square root 3, and 2a. Across from the 30 was given. So those make it easier because I don't have to solve for a. So a is equal to 6. And wherever I see an a, I just put in 6. So 6 square root 3 and 2 times 6 is equal to 12. Now this one, you're given across from the 90, right? So 30, 60, 90 pattern states that you have a square root 2, 2a. Now, if you could look at this and say, oh, a is 10. Oh, it's square root 3. Oh, even I make mistakes sometimes. Right here, if you could just, I was thinking about cutting it in half, as that's why I put the 2. If you could just look at it and say, oh, a is 10 because 2a is equal to 20, so you divide by 2. If you could do that in your head, you don't have to show the work because, again, this is trying to get you to do the pattern. So across from the 30 would be your 10. And then across from the 60 would just be 10 times the square root of 3. Now, those are the mild ones. These are the main part of your quiz. I did challenge you and put some harder ones here. So I'm given across from the 90 on this one, right? And I know 45, 45, 90 is a square root 2. And I'm sad because I'm given across from the 90, which means I have to solve for a. I do this just to emphasize you have to solve for a. So a square root 2 equals 6 square root 10 over 5. So when you're dividing by the square root of 2, that just means you're putting it in the denominator instead of in the numerator, because this is a division sign here. So you would write it like this. These cancel here. Because both of these are in the radical, you can go ahead and divide by 2. There's a little card. You go ahead. I'm listening. Yes, because you were given across from the 90. Put it under the denominator. So what's 10 divided by 2? 5. So this would be 6 square root 5 over 5, because you can divide these two because 10 is divisible by 2 and they're both under a radical. So that's what A equals. So across from the 45 would be 6 square root 5 over 5, and that would be for both of these because they're both A. Do I need to repeat that, explain that a little bit better? Time for it. We did on that Thursday. I think we did on that Thursday after the test when I had, or before the test. Oh, but yeah, it was a long time ago, and that's why we do the do nows, so that way I catch any. Because if you only do things once or twice, you forget it. Any questions on that? Can I move on? Okay, so I'm gonna move on. So this one is, they give you across from the 30 on this one, right? And if I'm given across from the 30, I'm happy because I don't have to solve for A. I just know what A is right off the bat. A is 5 square root 6 over 3. Oh, I forgot to put my pattern. I'll put it up here. A square root 3, 2A. So this one I'm just multiplying by the square root of 3. When you're multiplying, you'd put it in the numerator. When you're dividing, you'd put it in the denominator, right? Does that make sense? Okay, so this one you do 5 square root 6 times square root 3 over 3. And I get 5 square root 18 over 3. I am not done though, because 18 can be reduced. What perfect square goes into 18? 9. So that's actually 5 square root 9 times 3 over 3. This 9 can come out as a 3, and I multiply. 3 times 5 is 15 square root 3 over 3. And if you had my calculators, you could have just multiplied, and it gives you those. These type will just give you the answer. Like if you multiply this, but you got to use your N over D button to make a fraction, push out, and then multiply by square root 3. It will actually simplify it for you. Okay. Okay, so you want me to redo this one? Okay, it was 5 square root 6 times square root 3 over 3, right? Oh, wait a minute. I'm not done yet. You are correct. This is 5 square root 3 because I didn't finish it off. 15 can be divided by 3. I'm so sorry. Okay. So 5 square root 6 times the square root of 3, because this is a square root 3, right? And a is this. So I'm just multiplying by the square root of 3. That's 5 square root 18, because 6 times 3 is 18. Then, because there's a perfect square inside of 18, I need to simplify that. the square root of 9 is 3. 3 times 5 is 15. But now I have to divide this. 15 can be divided by 3. I didn't finish it. So it is 5 square root 3, Troy. Because when I divide this out, it should be 5 square root 3. What? Oh, yes. So you are right, and I'm wrong. Gosh dang it. I woke up with an upset stomach, and I'm just not right today. You multiplied. Five, A is 5 squared 6 over 3. Across from the 60, you would have to multiply this by square root 3. You, you want me to read? Okay, let me redo this. I'll write it bigger. Okay, so across from the 60 is a square root 3. I have to take this 5 square root 6 over 3 and multiply it by square root 3, which equals 5 square root 18 over 3. We're multiplying because that's the pattern. A square root 3 to A. A is 5 square root 6 over 3, right? And now this is where I made my mistake. This should be 5 square. I put 9 times 3. It's 9 times 2 over 3. This can come out as a 3 and you multiply those. That's 15 square root 2 over 3. Now you divide because 15 can be divided by 3 and this becomes 5 square root 2. And that's the across from the 60. Now, across from the 90, you would do 2 times A is 5 square root 6 over 3, which is equal to 10 square root 6 over 3, because 2 times 5 is 10. So your answers were across from the 60 would be 5 square root 2. Across from the 90 would be 10 square root 6 over 3. And I definitely won't give you one of these types that's that difficult on the quiz unless it's bonus. I may do that as bonus. Okay? Make sense? Doesn't make sense, but I could give you one of these because this one wasn't as bad, but I wouldn't give you one like this as unless it was bonus. Just multiply the coefficient in the numerator. Yeah. No, because it's just multiplication. Because there's no way to cancel a 3 and a 2. Okay, so 2 over 1 times this fraction would be 2 times 5 is 10. Square root 6. 1 times 3 is 3. Right? Okay. So this one we're given across from the 60. And if it's across from the 60, you know that a square root 3 has to equal 7 square root 15 over 10. What would I do to both sides to solve for a? We can. I was just trying to give you more room because people were saying they couldn't see. There. So what would I do here to solve for a? How do I get rid of this square root 3? And when I'm dividing, that means I'm just putting it in the denominator. So then this and this cancels. And I get a equals, because square root 15 can be divided by square root 3, you go ahead and do that. They're both in the square root. What is 15 divided by 3? So this then becomes square root 5. So you would write 7 square root 5 over 10. And that would be what's across from the 30. Would be 7 square root 5 over 10. We have across from the 60. So this would go right here. Now, 90, I have to take this a and multiply it by 2. So I'm doing across from the 90 would be 2 times 7 square root 5 over 10. What's 2 times 7? 14 square root 5 over 10. Oh, 10, but this can be reduced. You could have cross canceled over here and just canceled out the 2 and the 10. Or you could do it here because both of these can be divided by 2. This would be 7 square root 5 over 5 because 14 and 10 can be divided by 2. Or you could have done it right here and cross canceled, Troy, like you talked about before. But either way, you would get this for across from the 90. That'd be the cross from the 90, that'd be your x. Across from the 90. Do you need a cough drop? How? Do you need a cough drop? I have some cough drops. Here, take some. Yeah, it's okay. Take some for the whole day. There you go. Okay, so the two answers are this one and this one. So y was across from the 30. So this would be y. And then this one would be your x across from the 90. This is more like the spicy one I'll have on the test. Everybody, did you hear that? Okay, I gotta say it louder. Okay, I won't say it louder. I will write it right here. Is that better? This would be the one that'd be similar on the test. So if across from the 40, we know that we have a 45, 45, 90. We know that would be a square root 2. Across from the 90 is what? 6. But I have to solve for a because I'm not given the smallest side. So I have to do a square root 2 is equal to 6. How do I solve for A? By square root 2. Square root 2. This cancels. A is equal to 6 over square root 2. But I can't leave it that way. I have to rationalize the denominator. How do I rationalize the denominator? Square root of 2 over square root 2. This becomes, the numerator becomes 6 square root 2. The bottom becomes 2. But then these two can cancel. 2 goes into 6. How many times? 3. This is a 3. 3 square root 2. So this is 3 square root 2, and this is 3 square root 2. So x and y are both 3 square root 2's. So this would be more like the test, and then I wouldn't, if I do one of these, it would be bonus. These really hard ones here. Chances are I would give um, not fractions like across from the 60 or across from the 90. I wouldn't give fractions. Okay, so now we're switching gears, and this is geometric mean. So when I'm in the middle, the geometric mean is which one's the geometric mean? X, 25, or 56? X. Remember, your geometric means come off the big triangle. It's either this leg, or the middle. And in this case, it's the middle because that's what they're looking from, which is also called your altitude or your height. Geometric mean means that I'm going to have to see it in two places on the fractions proportion. So you see x up, you see x down. Now, what am I going to place right here? 25, and then what am I going to place over here? 56. Now, I'm going to be smarter than the average bear, and I'm just going to leave them like that because I don't want to work with too big of numbers. Because when I take the square root, I'm going to have to simplify, right? What is the square root of 25? 5. So that comes out as a 5, right? Now, square root 56. What is a perfect square? If you have your factor chart, look at 56. What's the largest factor that can go into 56? Let's see. Can 16 go into 56? No. Can 4 go into 56? Yes. So it's 4. 4 is the biggest perfect square because it's 4 times 14. 14 has no perfect squares because that's just 2 and 7, and those aren't perfect squares. So I'm going to pull out the 4, right? What's the square root of 4? 2. So 2 times 5 is 10, and I'm left with a square root of 14 on the inside. Now, if you have one of my calculators, it may have done that for you if you multiply it out. The blue calculator. Not those blue calculators, the light bluish ones. One Asala's holding. Okay, so now I'm looking at number 10. Number 10, which one of these is a geometric mean? X, because it's coming off the big triangle. Now, when you have the leg, you use the side it touches and then the whole hypotenuse. How do I find the side it touches? Yeah, I have to take 64 minus 16. What is 64 minus 16? 58? So, oh, 48. 48, yeah. Okay, 48. Everybody agree? I have no other choice. Okay, so if x is the geometric mean, what does that mean when I set it up? I'm going to have x up, and I'm going to have x down. What two numbers am I going to put here? 48 and 60, 64. Now, so when I cross multiply, I'm going to get x squared is equal to 64 times 48. I'm leaving it like that so I can simplify my radical easier. Because when I take the square root of this, I know that 64 is a perfect square. What is the square root of 64? Yeah, this comes out as 8. What is the largest perfect square that can go into 48? 16 times 3. So what's the square root of 16? 4. So this comes out as a 4. What's 8 times 4? 32. Square root 3. Right? 4 times 8 is 32. And I'm left with a square root of 3. I knew I shouldn't have wore this sweatshirt. I am getting really hot. Okay. So here for number 11, which one's your geometric mean? For for 11, what's your geometric mean? Your geometric mean is 48. So in this case, you're going to put 48 up, 48 down, and you use the two pieces because it's in the middle. So you put x and 36. 36 times x is 36x equals, what's 48 times 48? Oh, 2304. 2, 3. Let me make that like that. Okay, so I'll cross that out. And now what do I do to both sides to solve? Divide by 36. So x is equal to 64. Okay, now I'm looking at this one over here. Right? I have the outside piece. What's the geometric mean then? And you see 60 up, you see 60 down. You have the side it touches and the whole thing. So that'd be 36 and x. So this would be 36x equals 3600 divided by 36. X is equal to 100. Oh, yeah, you can take a break. Go ahead and take a 10-minute break if you need it. And then I'll be pulling up to our trig. This, I can pass out. They're taking a little break because the do now is a little rough. That when I first started teaching this, the calculators that students had did not have sine, cosine, tangent on the calculator. And because of that, I had to print out booklets that students would use to look up all of these numbers. But because now we are more advanced calculators, you are able to actually find these on the calculator itself. They are stored numbers inside the calculator, okay? So whenever I'm talking about the sign of some number, it's a stored number in your calculator, okay? It's an actual decimal. For well, tangent can be a whole number. Okay. Well, this is the same thing. This one's the same thing. Okay, so sine of theta, theta just means an angle. You could put an X, but mathematicians tend to use that little zero with a line through it. That's a Greek letter that means theta. So sine of theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Now you have to be careful because depending on the angle that you're referencing, they can change. Okay? So in this case, our the angle I'm looking at is right here. Put away your phone, please. Oh, well, we're doing notes. You want to do the notes right now because you don't want to get lost. Here. Okay, so here's theta. Opposite, when I'm talking about opposite, I'm talking about across from the angle. Crossing the street is opposite. When we do these, you are going to be labeling your triangles based upon the angle that we're mentioning. You're going to label. So across from the angle is opposite. Then across from the 90 is always your hypotenuse. And then the leftover one that you haven't marked yet, it helps make the right angle, okay, is adjacent. So you always label adjacent last. So let's look here. Yeah, you're supposed to write it down below where it says trigonometry ratios. Write the ratios below. It says it right on the paper to do that. So you're going to write sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. Tangent theta equals opposite over adjacent. Now, I love it that you can take pictures nowadays. However, there is something said to be using your hand and actually writing notes. You're using your brain more and you tend to remember it a lot better. So please write these down where it says trigonomic ratios. Write the ratios below. The ratios are right there. That has never been an issue in any of my other classes, so I'm kind of confused on why it's an issue. Okay. Okay, that's fine. Jay, Jay. Okay. Does everybody have it written down? Okay. Well, I'm. This is the angle that they referenced. Opposite is across. Hypotenuse hasn't changed since we've been doing Pythagorean theorem. It's always across from the 90. Adjacent is the only one really we haven't talked about. If you label your opposite and label your hypotenuse, adjacent is the last one. It helps make the right angle, but it's not the opposite. Okay? Only right triangles. Correct. There are other trig functions that you can use when they are not right triangles. Okay. This is just a mnemonic aid people have used for years. They just say SOHCAHTOA because sine equals opposite over hypotenuse. So they're just using the first letter of each one. See here how it has SOHCAHTOA. SOHCAHTOA. Now, I've been to a conference before. I'm only going to say this once because Miss Jerry may get mad at me. But it was a conference I went to that a speaker said this is one of the other ways to remember this. And I'm only going to say it once. Some old hippie caught another hippie tripping on acid. That's the other way. You've heard it before? Yep. You can. That is another way to memorize it. Old hippie caught hippie tripping on acid. Do you know what a hippie is? Hippies are people in the 70s that did a lot of drugs. Now, now I did modify it when I taught middle schoolers and said some old hippos caught another hippo tasting old apples, but yeah, or you could use Sokotoa, or you could use your notes. Okay, so how this works? It's asking for the sine of x. I'm also going to say something that a lot of teachers probably shouldn't say, but I'm going to say it anyway. Give the triangle your finger. Okay? Actually, put your finger or your pencil on X, or you're not going to get this right. Because it said sine of X. See here how it says sine X? Okay. So, opposite. Opposite means I cross to the other side. That's what opposite means. I'm crossing the street. I'm going opposite. Now, where's the hypotenuse? Hypotenuse is always across from the 90. So this is the 5. So I call that hypotenuse. And I just abbreviate it by using OPPHYP. And then what am I going to label the 4? Adjacent. Now, here they're just asking for the ratios. So the ratios mean fraction. You're not solving anything. They just want to know what's the ratio of the sine of x. The ratio of the sine of x would equal opposite over hypotenuse. What was opposite? 3 over, what's hypotenuse? 5. That's it. So now we're going to go to the next one. Cosine of x. Give the triangle your finger. Where's x? Well, it's right here. It's an angle. Because when it's next to the trig function, you're talking about the angle. So now I'm going to label opposite first, which is, no, it's opposite. It'd be, yeah, this one over here is opposite. Okay, now I'm going to label the hypotenuse. Cross from the 90, hypotenuse. And now I label the adjacent. Which one's the adjacent? The 9, the one I haven't labeled yet. Okay, cosine equals adjacent over hypotenuse. What's adjacent? 9. What's hypotenuse? 41. Now, neither one of these fractions could be reduced. But if it can be reduced, you have to reduce the fraction. But 9 and 41 is prime, so it can't be reduced. Okay, so this next one. D, they changed it up on us. Give the triangle your pencil or your finger. Actually put it right on Z. Because it changes if I accidentally put my finger on X, right? So here's Z. Where's opposite? 20. Where's hypotenuse? 29. And what am I going to put as adjacent? Now I make my fraction. Tangent is opposite over adjacent. So what's opposite? What's adjacent? And again, I can't reduce that fraction. So let's do this one. We're going to label it again. I'm going to wait and let you try doing this one yourself. So, and then check with your neighbors, see if they get the same answer as you got, and then I'll tell you if you're right. Don't forget to reduce your fractions. 20 over 21. And reduce your fraction. Okay. Math enter, enter. Those calculators will reduce fractions. You need to use the ABC button. You would put your numerator, and then you hit ABC and put the denominator, and then press enter, and it will reduce your fraction. You want to use the ABC button. So did you all get the right answer, you think? Am I ready to put it down? Simplify. So here's A, right? So this is opposite. This here is hypotenuse. And then this one here is adjacent. Cosine is adjacent over hypotenuse. 14 over 50, which when I reduce my fraction, that is 7 over 25. Everybody gets 7 over 25. No, what happened? Oh, okay. You forgot to reduce. Okay. So next time, reduce. Do you want me to show you on those calculators how to reduce real quick? Uh, yeah, on those. So, so you have an A, B, C button right here, right? Right here, A, B, C. It's next to LN. So you would put 14 A, B, and you get this little mark, and then you're gonna put 50, and then you press enter, and it reduces your fraction. There. So put 14, go to AB, put 50, press enter. It's just 50. You had it, but you put a plus for some reason. 50. Anybody else? How about that? Well, you can't because you have a different fraction. Yours was 14 divided by 50. Enter. And then you go math, enter, enter. Okay. What? Huh? Well, they took a break at, no, I need to finish this, so, and you came late, so you can stay, and you already left the room once, so, I'm teaching, no, I'm teaching, and I'm recording. Okay, so, everybody was able to do that, I hope? So, here's X, honey, you're in the way of people. Okay, here's X, so, you're gonna have to go opposite, right? And then where's the hypotenuse? And then adjacent, right? And then how do I write the fraction? No, it's up. Oh, yeah, you're right. 24 over 7. I was going to say wrong, and here you're right. Sorry. Always. Just like in Pythagorean theorem, right? A squared plus B squared equals C squared. C is always your hypotenuse. It's a It would always 90 will be the largest angle because it's a right triangle. Yes. Side. It'll be the longest side. Yes. Yes. Okay. So we're going to do one more of these, and then I'm going to show you how do you actually use this. So over here you have sine of A. I'm going to put my finger on A, right? And now you're going to label opposite. You label hypotenuse. And then you label adjacent. Now, I know that sine is opposite over hypotenuse. So it is 35 over 37. And that can't be reduced. Okay, so next one. Now, this is how we are going to use the trig functions to find missing side lengths. So this would be a typical problem here. The only angle I have is the 24. So I'm going to put my finger on 24. I'm going to label my triangle just like I labeled before. So this side is opposite. This side is hypotenuse. This side here is adjacent. Now, I'm going to circle what I'm looking for, and I'm going to circle the number that I have. Is there anything with the adjacent? No, I'm not even going to mess with the adjacent at all. So, what trig function, look at your notes, uses opposite and hypotenuse? Sine. We don't sin in math class because we're all really good people. We sign in math class. So, you would write, that tells you, this here tells you what trig function you're using. You put the angle right next to it. So sine 24 is equal to opposite over hypotenuse. Now you're just cross multiplying. So I'm multiplying 283 times sine of 24 and x times 1. I usually put the number in front of the trig function because sometimes people forget to close the parentheses and then they get the wrong answer. So now you use your calculator. What is 283? And when you have this number next to here, it's just multiplying. You could put a times in between if you want to, or you could just put sine 24 and then press enter and make sure you get 115.1, because if not, your calculator could be set to a different setting, and I need to fix that, just like I fixed yours.
Yeah, you don't have to do it again because I think I messed up.
No, put sine 24. Now press enter. Did you get that? Yep. You're going to need a calculator here. Yes. Because there's an equal in between. Anytime you have an equal in between, you cross multiply. If it's something that is right next to it, you just multiply straight across. Because this is what we call a ratio. So very much, everybody, I'm trying to answer a question. A very good comment. She said, well, when we were doing the special triangles, we just multiplied straight across. But then when we're doing these, we're doing the diagonals. The reason why you do the diagonals here where we're cross multiplying is this is a ratio. There's an equal sign in between. Okay, just like when we did similarity, there was an equal sign in between, so you cross multiplied. Okay? So let's try this next one. Where am I going to place my finger before I even start? At the 29. Where the degree is where you put your finger. Because I need to know, I have to label this triangle before I start. So across from the 29 is what? Opposite. Across from the 90 is what? What am I going to label the 20 as? Now, circle. I am looking for X. I have adjacent. You circle what you're looking for in the number you have. This will tell you now which trig function you're going to use. It's sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals adjacent, no, opposite over adjacent, sorry. Opposite over adjacent. So now I have adjacent and hypotenuse. So which one do I use? I use cosine. So I do cosine 29 is equal to Adjacent goes on top. Hypotenuse goes on the bottom. I'm going to place this over 1, and we're going to cross multiply. X times cosine 29 is x cosine 29 is equal to 1 times 20, which is 20. How do I solve for x? Yep, you divide by cosine 29. Remember, cosine 29 is just a number stored in your calculator. So you treat it like a number. And so now you would just put in your calculator 20 divided by cosine 29. And what do you get? 22.9 is what you would round it to. Because it said round to the nearest tenth. And that makes sense because it's the hypotenuse. It better be bigger than the adjacent side or I did something wrong, right? Because the hypotenuse always has to be the longest side. Jay, Jay, did you do this on your calculator? Yeah, how are you going to know how to do these? Well, yeah, let's not because you can't do that when learning new material. Okay, we'll try and do, I want you to pay real close attention to this next one. Oh, so, okay, so where am I going to put my finger for number 8? At the 70. I'm going to go ahead and label. Always label your triangles. And on your tests, if you label your triangles but accidentally use the wrong trig function, I'll give you a little bit of credit if you labeled your triangle correctly, right? Because I give partial credit. So, where's opposite? The x. So label this as opposite. Where's the hypotenuse? There's nothing there, right? And then what do I label as adjacent? 16. So I'm going to circle the one that I have and the one I'm looking for. I'm not worried about the hypotenuse because I'm not looking for it. So which trig function uses opposite and adjacent? Tangent. And so it'd be tangent 70 is equal to x over 16. I'm going to place this over 1 and I'm going to cross multiply. So when I cross multiply, you get 16 times tangent 70 is equal to x. And go ahead and do that on your calculator right now. Put 16 tangent 70.
I mean 43. Oh, 44.
Is it going to be 44?
Yeah.
Which, yes, you would round that to 44. Okay, now this is different. And I made a little rhyme. When looking for a degree, use your second key. Now, I don't know on these new calculators that you're using what they have. Yeah, they have a second. Do you all see that the second key, it's the blue key? Okay. So when you're looking for a degree, use the second key. You still label everything, but now I'm looking for the angle. Okay? So here's the angle. I still label my triangle the same way. This is opposite. This here is hypotenuse. And that doesn't look like a Y. And this would be adjacent. I'm going to circle the ones that I have here. What uses opposite and hypotenuse? So sine of, and I could use a theta or I could use an x. Students get confused when I put theta, so I'm going to use an x, is equal to 33 over 58. Now to actually get the answer with your calculator, hit the second key, and you're going to hit sine. And when you do that, you should get like a little -1 that comes up. That means inverse of. And you're going to put 33 divided by 58. And then press enter. So that would be 34.7. And that would be a degree. Oh, but it does it say to round? Sometimes they, on the degree, they have it round to the nearest whole, which it would be 35. Oh, okay. Where does it say that? Well, for the nearest tenth would be 34.7. If it says to the nearest whole, then it'd be 35. So now let's try this one. Okay, so I'm going to label my triangle. What do I label the 57 as? Opposite. What do I, and then I go to the hypotenuse, it's across from the 90. And then what am I going to label the 24 as? Adjacent. Now, I have adjacent and I have opposite. Which trig function uses those two? Tangent. So tan x, because I'm looking for the degree, is equal to 57 over 24. But because I'm looking for the degree, you have to use the what? The second key. So you're going to do second tangent, which should put tangent at like a little -1. And probably put a parenthesis around it or not. I don't know on those blue calculators. 57 divided by 24. It means inverse of. When you have a -1 as an exponent, that means inverse of. But that's what should come up when you put second tangent. So what was the answer one more time?
67.1.
67.1. That's degrees. What? No, it's when you're looking for a degree and you press that second key is when you get that -1. Because you're trying to find the inverse of, you're not trying to find the length. So that's why you use the second key. Okay. So my finger go. This one was wrong. It should have been 67 point. Mm-hmm. 67.5. Okay, so I'm going here. I'm put my finger right here, and this goes. That's opposite. Where's hypotenuse? And then I label adjacent. I have adjacent, I have opposite. So which one am I using? Tangent. So tangent of x has to equal 26 over 44. But to solve, because I'm looking for the degree, you hit the second key. So second tangent, which should pop up with like a little -1. 26 divided by 44. So it's 30.6 degrees. Okay. I thought that was the last one. Okay, so is this one on there? Okay, so I must not have had that one. So this is a word problem. When I took everybody out, yeah, this one. But I okay, when I took everybody outside, I don't know if anybody noticed that I took my geometry class outside last time, and I do this as a project. I'm gonna wait till it's a nicer day because this week it's supposed to be rainy and cold and it's winter, so we may not go outside and try and do it. But this is actually what we do. We find the angle of elevation by using a protractor and a weight, and then we use trigonometry to find the heights of like the flagpoles, the building, some trees. In this case, this is the Washington Monument, and the elevation means that somebody is looking up, right? Now, because her eye height is right here, we end up having to add 5 feet to the actual height. Because when I'm calculating it from when I'm standing, I'm only calculating it from where my eye is at because I'm looking up. So when we find this answer, we end up having to add 5 to it at the very end because of our height. So if this is 87 degrees right here, this would be considered my opposite, right? This would be my hypotenuse because you would hope that the Washington Monument is standing up nice and straight, so the right angle would be here. And this here would be your adjacent. So you have adjacent, you're looking for opposite, right? What function is opposite and adjacent? Nope, tangent. It's tangent, and then it'd be 87.4 is equal to x opposite over 25. Has anybody ever seen anyone with the little tripods out on the roads? Like they have these little tripods and they have the yellow jackets. This is the math that they're doing. The surveyors are using trigonometry to figure out their measurements. Nowadays, some of those surveyors are using drones. So if you want a fun job using drones, you may want to think about becoming a surveyor. My son had to do a little bit of surveying because he's doing CAD drawing for a wastewater company, and he did a little bit of surveying. Not with the drones, though, but okay. So I'm going to place this over 1 and cross multiply. Then I get 25 times tangent 87.4 has to equal x. And what do I get for that answer? What's 25 times tangent 87.4? What is it? Oh, I still couldn't hear you because that darn phone. 551. Did it have a point to it? So I'm going to put 0.5. And then you have to add her eye height to it. So you're going to add that 5 feet of her eye height. So then this would be 556.5 feet. Oh, it's a 0? Oh, yeah. So it's 500. So then this should be just a 5 here? Okay. And that's not what, I don't know if they asked. It didn't say, so I can't mark her wrong on that one. But if it, you have to be careful because in the instructions, they'll tell you when to, how to round. Okay, that's how you do those. So I'm going to go ahead and give you